Okay, illustrative math, Algebra 2, Unit 2, Lesson 16 is called Minimizing Surface Area. All right, so our goal today is I can create a rational function to model the surface area of a cylinder of known volume, and I can create graphs of rational functions in context. So when you look at this here, we probably know what surface area is, and we probably know what a cylinder is. We know what volume is, but the one that we're probably not too sure on is what a rational function is here, okay? So a rational function, here's a definition. A rational function is a function defined by a fraction with polynomials in the numerator and the denominator. Rational functions include polynomials because a polynomial can be written as a fraction with a denominator of 1. Okay, so the second part here, the second sentence, yes, technically, but we usually don't refer to straight polynomials as a rational function. So let me give you an example here. If I have a polynomial here, x squared plus 3x minus 1, and then another polynomial here, let's just say it's x plus 3. This one here is quadratic because the power is 2 or has a degree of 2. This one here is linear because the highest power is 1 right here, even though we don't write it on the x. If I wanted to make it a rational function, I would just have to divide them, okay? So I divide that function right there, and I'll call it equal to f of x, so it looks like a function is my polynomial, okay, my rational polynomial, okay? All right, so here's a warm-up. Here's 4 cylinders that have the same volume. So same volume, basically, if I were to take water or sand or concrete or whatever and fill these up, I would use the same amount of water, sand, or concrete to fill cylinder A, B, C, and D. Now, which one needs the least material? So, say I made my cylinder out of, I don't know, metal. Which one would use the least amount of metal? So, there's all kinds of different answers here. We don't really know the answer here. There's not enough information to answer this. So it's just basically going to be a guess. I think most people would say D because it's the shortest. All right. Some people might say A because the circle is the smallest on the top and bottom. Or instead of the circle, you could call that the base is the smallest. All right. Some people might just have a hunch that B or C is, but again, they're just guesses. So what information would be useful to determine which cylinder takes the least material to build? So I want you to think about this here. On a cylinder, the top, if I were to think of area, think about like wrapping a present. Everybody's probably wrapped some sort of present that's a cylinder, okay? And on the top, it's a circle. So it's almost like you have 2 circles here. Like, so I'm going to use this one right here, this cylinder on the right, cylinder D. Almost like I got a circle on the top and a circle on the bottom. But then the middle is actually a rectangle. If I were to like take this side of D and think of this like on the side like a label of a can of soup. And if I peel off the label, what shape is it? Well, it's a rectangle. Okay. So the rectangle is actually a height. Let me move these. Almost looks like a division sign there. Kind of cool. So the height of the cylinder right here gives you one side of the rectangle. And then this is actually the circumference. So, this is a circle here. And area of a circle, if this is my radius, is pi r squared. And this is my height. And then this side here on my rectangle is the circumference, which is equal to 2 pi r, or pi times diameter. So the area of this rectangle is going to be the circumference times the height. So 2 pi r times height. And then this is the same exact circle as below, radius r. This area equals pi r squared. So if I find the area of this rectangle, it's going to be 2 pi r times the height. So basically the total surface area is going to be pi r squared times 2, because I have two circles, plus the area of the rectangle, which is 2 pi r times h. So I guess what would be useful would basically be the radius and height. Okay. All right. So kind of like the warm up, there are many cylinders with a volume of 452 cubic centimeters. Let R represent the radius and H represent the height of these cylinders in centimeters. So I already went and filled these in, but what I'm gonna do is I'm maybe do like, a couple of these here for you. I'll highlight, two of them or three of them. All right. Maybe right here. I'll do these three. So volume of a cylinder is gonna be area of the base, which is a circle. So pi r squared would be the area of the circle times the height. So if I know the volume is 452, I'm going to do the first one that I highlighted. It's going to be pi times radius squared. So I'm pretending I don't know this 36, okay? So maybe I'll just erase it here. I know it's 36, but it won't let me erase it. All right, I'm just going to pretend it's not there. So pi times radius squared times height. So what I end up with is 452. This is 4, so 452 equals 4 pi. So then if I divide by 4 pi, I get h. Now, when you divide by 4 pi, it's very important that in your calculator you do 452 divided by, make sure you put the 4 times pi in parentheses. Otherwise, your calculator will just divide the 452 by 4 and then times it by pi, but you want to divide by both of those. Okay, so these end up canceling. So I get h, if I take my calculator, 452 divided by parentheses 4 times pi, I get 36. Okay, so that's how I got that one. If I go down here, my radius is 4. So everything stays the same. I just change my radius to 4. So I'm going to erase and kind of do the same thing here. So my radius was 4 squared. So that would be 16 times pi times h. So when I divide by 16 pi, that should give me my height that goes with that radius. So I'm going to divide by 16 pi. Make sure you put in parentheses. And I get 8.99, which is where I got the 9 right there. Okay, and I guess I don't need to do the next one that I said I was going to do. All right, so there's my table. So use graphing technology to plot the pairs r comma h. So this is, see how the r is written first. We're thinking of r as x and h as y. Okay, so we got x, y right there. So think of the radius as x and the height as y. So I'm going to plot all those points, and I'm going to take a look at the graph. So let me just delete that. I already did that. So what do you notice? Well, I'm noticing here that as the radius gets bigger, because this is my radius here on the x-axis, and this is my height. So as the radius gets bigger and bigger and bigger, the height eventually levels off. Okay, and you can kind of see it looks like almost like an exponential decay. It's kind of getting smaller and smaller and smaller that way. Probably won't ever cross this axis because it's never going to get negative, because you can't have a negative height, because if I cross the x-axis, the y-coordinate, or the h-coordinate, I should say, would be negative. You're never going to have a negative height. So here's all the points. I plotted them right there. I typed them in on Desmos. I went to desmos.com, graphing calculator, and I hit the table button, and I typed in all the radii here from 1 to 10, and I typed in all the height, and I kind of found them all ahead of time to make things a little bit quicker, but I showed you how to do it. All right. Now, we're going to talk about surface area. So we kind of already went over the formula here for surface area of a cylinder. Surface area is going to be 2 pi r squared, so 2 circles. And then the rectangle on the side is basically the circumference, which is 2 pi r times the height. So let's see here. Let's read this. Use the table to explore how the value of r affects the surface area of the cylinder. So I kept these same values that I had. I had 3, 16. So if I go back here, 3 was with 16. For a radius of 4 would produce a height of 9. So I went right here. Basically, I almost added on an extra column here, and they're all still same volume, 452. So I picked some of these, and I found a few more here. I don't think we had 3.5, 3.75, 4.25, 4.5. I went ahead, I plugged those in for R, and then I solved it to find the corresponding height. I went and did a little bit more work, but just to show you how I did that, remember 452 equals pi r squared times height. So I did, 3.5 squared times pi times their height. So basically, if I divide by 3.5 squared times pi, so I'm going to type it in my calculator. 452 divided by parentheses 3.5 squared times pi, and that's where I got the 11.7. Okay, and I went and did that for these other numbers as well. Okay, so let's start calculating the surface area here. So I have the radius, I have the height, I can plug them into this formula. So I'm going to do a couple of them for you, and then I'm just going to kind of fill them in. So let's start with the first one. 2 times pi times radius squared plus 2 times pi times radius times height. So go ahead and calculate that, and you should get 357.9. Then I go to the next one. It's 2 pi times 4 squared plus 2 pi times 4 times 9. And when I go ahead and do that, I should get 326.5. And then I'm just going to kind of fill in the rest of these now that you see how to do it. Okay, so there you go. There's your table. All right, so I'm going to go take a look at number 2. Use graphing technology to plot the pairs RS. So RS, X, Y. So we're thinking of this as X, surface area is Y. So on my Y-axis is surface area, and the X-axis is radius. So number 3 says, what do you notice? And then write an equation for S as a function of R. So here we go. I'm on number 2 here. So I basically took those points. If you look here, these columns here, I made a table, and it looks like that. Okay, this is my R and my S right here. S, R. And this time it's not flattening out. If you notice here, it comes down and then comes back up. So if I were to connect this, it looks like kind of like a relative minimum down here, okay? So what do you notice? I would say a relative minimum at, looks like it's maybe right about here, 4.2, 4.2, and then the y coordinate looks like, I don't know, 320 maybe. I don't know. I'm just kind of guessing here. I would definitely want to be lower than these numbers. So yeah, 4. Yeah, 4.25 is at 326, maybe 324. I don't know. Hard to tell there. But yeah, definitely relative minimum. So write an equation for S as a function of R. So when I see S as a function of R, this means I want S equals, and then my equation here, I don't know what it is, but the only variable is, so that's supposed to be a question mark. The only variable I need is R, okay? Can't have any other variables in there. So when you look at our function that we had, S equals, or think of it as S of R. How about that? Let me rewrite that. Think of it as S of R. Surface area with R as my variable. So if you look there, we had surface area equals 2 pi R squared plus 2 pi R times H. So the problem is this H in here has got to go, all right? H cannot be in our equation. So let's rewrite it as S of R this time. 2 pi R squared plus 2 pi R. Now, if you go back to a couple slides here, I never finished this last one. I left it blank there. If I said, what is it equal to when it's a radius of R? So I'm going to go here and I'm going to finish this. 252 equals pi R squared times H. So I want to find out what H is. So if I divide by pi R squared, I end up getting H equals 452 over pi R squared. So I'm going to write that right here. 452 over pi times radius squared. Okay, so now I'm going to go over here. I'm going to basically substitute this in for H because this is equal to H, so I can replace it. So I'm going to say, oh, okay, H was equal to 452 over pi times radius squared. And I'm going to basically plug this guy in for H, so I only have R. So S of R equals 2 pi R squared plus 2 pi times 452 over pi R squared. Now, when I'm multiplying here, this pi, oh, I forgot my R. That pi can cancel, and then this R can cancel with one of these R's. So my final simplified answer is S of R equals 2 pi R squared plus, I can multiply 2 times 452. I think that's going to be 904, I believe. So 904 stays in the numerator over R. So there is my final answer. So this is S as a function of R. So S of R, let me erase that, make that a little neater. S of R equals 2 pi R squared plus 904 over R. So I only have R in the equation. Now what we notice here about what our learning goal was, we have a rational function here because I have a polynomial. This is just a constant. A constant is a polynomial of degree 0. So that 904 is a constant divided by another polynomial. This is a linear. It's just R to the first. Okay, so that makes it rational now. All right. So which cylinder has the smallest surface area? So let's go ahead and calculate that. So remember, surface area equals 2 pi R squared plus 2 pi r times h. Now I can start plugging some things in here. So the first one is going to be 2 pi times 2 squared plus 2 pi times 2 times 36. Next one, 2 pi times 3 squared plus 2 pi times 3 times 16. 2 pi times 4 squared plus 2 pi times 4 times 9. And then the last one, you're basically doing the same thing. You're just plugging in different numbers each time. So I'm going to go ahead and calculate all those, and I'm going to find out which one is the greatest. So 2 times pi times 2 squared plus 2 times pi times 2 times 36. So this one has a surface area of 477.5. Next one, oh wait, yeah, that's right, yeah. Next one is 358.1. Next one is 326.7. And then the last one, oh, you know what? That was supposed to be squared. Whoops. Last one is 376.99, so I'll call it 377. So which one has the smallest surface area? The answer would be C. All right, so the answer is cylinder C, 326.7. Okay, so again, you're probably going to get that little relative minimum type of thing as your radius gets bigger and bigger. Okay. All right, so goal, I can create a rational function to model surface area of a cylinder of known volume. I can interpret graphs of rational functions in context. I would say yes, but this is still obviously very vague, very developing. All right, last thing here, a cool down. A can manufacturing company is designing a can of cat food to hold 5.5 ounces or about 163, that should say cubic centimeters. That should be up in an exponent. They've written out the equation for surface area of a can of volume S. Explain why the equation is wrong and how to fix it. Okay. All right, so go ahead, pause the video, take a look at that. So, whoops. So basically, I think the number that's wrong here is this 163 because you have 2 pi r squared plus 2 pi r times h. And when if my volume is 163, okay, my height is going to be 163. Remember, volume equals pi r squared times height. I need to solve for h. So it's going to be pi r squared times h. So if I divide both sides by pi r squared, I substitute this in for h because it's equal. So this part's right, the 2 pi r squared, but then it's 2 pi r times 163 over pi r squared. So my pi's cancel. One of my r's cancel. So that's all right. The problem is the 2 times the 163 is going to be 326 over r. So that would be my function. That would be best. Okay. So here's some other formulas. Volume of a cylinder, pi r squared times h. Surface area is 2 pi r squared plus 2 pi rh. All right. Hope you enjoyed this video. Thanks for watching.